Okay, Matrix, let's have a look at some exam questions that link grade 10, 11, and 12 all together. And here's a first example quickly. And what I'm going to give you is, I'm not going to write down all the words. What I'm going to do is I'm going to tell you what's going on. You've got a circle with center M. And we've got the points A and B that lie on the circle. In fact, B is the diameter, A is 0.5, B is negative 8, 1. And we've got the point C here as negative 12 minus 1. CTD is a straight line, and then you've got line AD. This is a tangent to the circle. AD is a tangent, and then K is the point 0, negative 7. And yeah, and we've got points C and D are joined there, and to form that lovely straight line there. Now, there's a few questions I want to ask you relating to this information. And the first one, number A, typical exam question, what would be the coordinates of M? Okay, M is the midpoint of the line segment AB there, and we want to find the coordinates of M. Okay, now remember it's a diameter, so all you have to do is you have to simply add up the x's, divide by 2, add up the y's of these two endpoints here. So how do we do that? Well, the midpoint M would be the point. Well, basically we're going to say the x of B plus the x of A divided by 2, and the y of B plus the y of A divided by 2 there. Okay, so let's add them up. The x of B is going to, of course, be then negative 8, plus what's the x of A is 0 there. Great. So it'll be 0 all over 2, and then the y of B, what's the y of B? The y of B is 1, plus the y of A is 5, so it's 1 plus 5 over 2 there. And there we've got it. The midpoint would be negative 8 over 2 is negative 4, and 6 over 2 is 3. So we've got the midpoint M there. The center, in fact, of the circle, so we can write it in there, negative 4 and 3 would be the center there. M would be the center of the circle. Okay, let's do another question quickly. Number B here. Okay, I want you to determine, so I want you to find the equation of tangent, so let's write this down, the equation of tangent AD. Okay, the equation of the tangent AD. So we want this equation of this line. Let's move that right up there so you can see the equation of that blue line, the tangent. Now, what do you know? You automatically know that the radius and the tangent, there's the tangent and there's the radius, are perpendicular, and we've got the points M and A. We can get the gradients of the radius and hence the gradients of the tangent. We've got a point on the tangent, 0.5 there. Okay, so let's do that quickly. Well, what would be the gradient of the radius? Let's have a look at the gradient of the radius quickly. If we work that out, if you have a look at these 2 points, you could say 5 minus 3, that's you subtracting the y's, 5 minus 3 over 0 minus negative 4. So that comes to 2 over 4, which is a half. So that's the gradient of the radius there. So we can easily work out the gradient of the tangent. So let's just go down and do this thing over here. And what have we got? So we've got the gradient of the radius is going to be a half there. Okay, that's the gradient of the radius. What would be the gradient of the tangent? Negative 2. Swap that around, change the sign, and a half times negative 2 is negative 1. So that would be the gradient of the tangent, which is actually the gradient of AD. So that would be the gradient of the line segment AD there. Okay, great. So once we've got that, we've also got the point 0 and 5 lies on that line segment there. On AD, it's the point of tangency there, 0 and 5. In fact, it's the y-intercept of the line there anyway. Okay, so what we can then easily do is say, great, this would be the gradients of AD is that, so we can say that y is equal to negative 2x plus 5. Remember, that's the y-intercept of the line, and that's m, and this is mx plus c. Or alternatively, what you could do is you could say y minus y1 is mx minus x1. So the y1 in this case would be, if that's x1, y1, the y1 is 5, the m is negative 2x minus 0 for x1 there. Okay, so it's all linking in. So it's y minus 5 is negative 2x there, and because that's x minus 0 is x, so that equals negative 2x plus 5. Another way you could do it, remember that this is the y-intercept of the line here. Clearly this would be the y-intercept, and you've got the gradient of the tangent, which is negative 2, so logically y must be negative 2x plus 5. Okay, let's have a look at a third question. And the third question I want you to do is to determine the length of AM. Let's look at the radius of that circle. Okay, how do we get the radius, the length of the radius? Well, let's see. If we summarize all that information, what do we have? I'm going to write down the coordinates quickly. For number C, we're going to find the length of the radius, that's clearly indicated by the length AM there. Okay, alright, what are the coordinates of A? 0, 5. The coordinates of M would be negative 4 and 3, because that's what we've worked that out previously. Let's have a look. Okay, so we've got M is minus 4, 3, A is 0, 5. Now how do we get the length? Well, clearly we use the distance formula. AM squared, let's get the difference between the x's. So it's negative 4 minus 0 all squared plus 3 minus 5 all squared. Remember, this is the distance formula. Negative 4 minus 0 all squared, 3 minus 5 all squared. So AM squared would be negative 4 minus 0. Negative 4 all squared is 16. Plus that's negative 2 squared is 4. So that is 20. So if AM squared is 20, then what do we know about the length of the radius? It's the square root of 20. And we can go back to our picture here, and we can say, well, the radius is the square root of 20 units, that little radius there, that length there. Okay. Alright, how about another question that they could ask you in the exam? Number D, a typical question, what is the equation of the circle? So let's go to number D here, and we're going to be finding the equation of the circle. And that's quite a classic question. Now, what do we need to get the equation of the circle? We need the center, which we most definitely have. So we've got the center, with the center being negative 4 and 3. And we've also got the radius as being square root of 20. So if we look at that, let's have a look at that, the equation of the circle. The center is negative 4 and 3, and the radius is root 20. So how does this work? It's x, okay, that's minus 4, so it becomes plus 4 inside the equation, plus y, and this becomes minus 3 squared, and the radius is the square root of 20 squared. Okay, so what would this give us here? X plus 4 squared plus y minus 3 all squared gives you the equation of the circle is, of course, 20 units there. Now, of course, if you want to, you can actually multiply it out if you so wish. X squared plus 8x plus 16 plus y squared minus 6y plus 9 is 20. So it's x squared plus 8x plus the y squared minus 6y is, okay, that's 25. Take it across, and you're going to get negative 5 there. Okay, and that would be the equation of the circle. Okay, now another thing that's very interesting is in number E. Okay, I wanna ask you something here. What type of quadrilateral? What type of quad is ACKD? What type of quadrilateral is ACKD? Now look at the picture here. ACKD, this thing here, what kind of quadrilateral is that? Well, if you think about it carefully, it's actually not too difficult to do, because if you think about it, that's 5 there, so that length is 5, and then this goes down to negative 1 at t, so that length is going to be 6. Alright, and then what's the distance from -1 to -7? That distance is 6 as well. So, in other words, and of course this is definitely a 90-degree angle there, because this line is perpendicular to the y-axis. So you can see the diagonal, the longer diagonal bisects the shorter diagonal at 90 degrees there, and so also, and because of that, you can immediately conclude that this must be a kite. It's a lovely link to your quadrilaterals. The diagonal CD bisects the diagonal AK at right angles there, and because of that, remember that this from that's 5 and that's -1, so the distance is 5 plus the 1 gives you 6, and then from -1 to -7 is a distance of 6, and you've got yourself a kite here.